Hello, good afternoon. It's me again. Okay. As I mentioned in the morning, today, this session, I'm going to show a demonstration, as I promised. This one is very special sample that we are going to demonstrate because in Taiwan, I know that ESG topic is very, very popular and getting more attention from everywhere. Energy saving, reducing our carbon emission is one of the top topic in Taiwan. Not only Taiwan, also Hong Kong, South Korea, Japan, everywhere. So I'm going to show you how you can reduce energy consumption using Minitab Workspace, Minitab Statistical Software, and also predictive analytics to predict future energy consumption as well. So this is going to be interesting demo. So hope you can understand most of them. I will start with some of the stats first. There are a lot of information out there that the carbon emission, the consumption is getting skyrocketing. At the same time, energy consumption is also increasing. As you see, the financial crisis in 2008, also during pandemic, there was a little bit of dip, but still the trend of spending more energy is inevitable. So today's example, I'm going to introduce one company. The name is Producer. We call Producer. This company operates in the metal industry and is challenged by the rising energy prices. So they want to achieve remaining profitable and protect their margin despite of this energy crisis. So management instructed to the project team to reduce energy consumption while maintaining the same level of quantity, not compromising with quality level. Second one is to quantify the solution, to find the solution that can be implemented quickly and easily. So not adapting new thing, new software, new solution, new system, just trying to improve the situation using what they have. The third one, last but the least, to find cost-effective solution for themselves. So no need to invest a large amount of investment to get this result. So the first one is the same level of quality. The second one is quick and easily. The third one is cost-effective solution. So we will see that thanks to this methodological approach, the project team could select the methodology and after the study, they could reduce the energy consumption by 20%, and which means saving around $84,000 per month. So this is a significant cost saving. So let me explain a little bit more about the project roadmap. The product team and the process teams met together to develop a possible solution. And then they identify the key drivers which can be improved and enhanced. And the third one was the findings of the analysis should be used to mainly drive short-term solution. And the team also wanted to be able to predict the energy cost in the future plan production. So first of all, we are going to use Minitab Workspace to find out the right methodology and define what kind of actions they can take based on the template, the consultation template that Minitab Workspace provide. For example, DMAG is one of them. And then we are going to collect data from Minitab Connect and use Minitab MSS to analyze the situation. So let's jump onto the data set. Data set, we have 23 columns and roughly around 12,000 rows. So as you can see, this information is very standard, the product information, each product information. When is it produced? What is when this product was produced and which product line it came from? Who was a supplier? Or what is the order number of this product? Pieces produced, pressure, push time, purity, air pressure, all information. This is quite. I believe this is quite standard data. So this whole 12,000 rows are installed in Connect. So you can see a lot of predictor from number 1 to number 20. So this is a predictor to get the output of how much energy consumption per piece and what is the yield. So you use those factors to get the output. So let's start. The first part is using workspace and using the methodology to define the project. So if you see the left part, those parts are the navigator that you can see this divided in 2 parts. The first type you can see in this red box is management tool, administration tool, and the second box is the roadmap. This is the phases you can see. So again, this time they used a DMAC process. So from the define, measure, analysis. So now the team already working on the analysis phase. So this box you can see is the how they are working on right now. This is work area. So, but if your company or your organization use different template, you can search other template in the search bar. Also, if you can see this custom project, you can also develop your own project template as well. So you don't need to just look at DMAC and this workspace only have DMAC. This has more than 100 tools, and you can also modify the project and form template, whatever you want. Like you see, if you can want to search different tool, you can see PDCA project. Yeah. Let's go back to the fishbone. This is a fishbone model. If you can see, we can see that the team has already started this project, laying down what are the options, defining, and also putting the details on each box, that what are the parameter and which are the affecting factors of this. And you can assign those priorities on each boxes, which are the most priority, has to be most prioritized on these items. And when you are done, you can also export to PDF or Word format so you can share with your team. So let's say you completed this process, laying down this process and plan. You have plan. So you go to the Minitab and get all the data into the Minitab and do analysis. So what you see is Connect. So, and all data are now cleansed already. So you will connect with, you will fetch the data from Connect from Minitab. So you can see this user is logging into the Connect. And you can select a table from the Connect and import those data into your MSS. And you can see, you can see that the data is from Minitab Connect data, and you can see this the logo there. That means this data is from Connect. Okay. And then you can see the worksheet information. And in the worksheet information, you can see the column, the count and the names of the column. You can see there are almost 12,000 records. before we start developing model, you want to see the data, meaning that you want to use graphical analytics tool, graphic builders, or graphical to visualize and to see the patterns of this data first. I think that's the normal process what we do, right? We import the data and use this visualize to see the how it looks like. As you can see, we are using graphic builder to build a graph right away and visualize the outside temperature graph. And you can see that the months of July, August, the temperature is going up. And this we can easily change to box plot of outside temperature. You can see the whole distribution of the data. Yeah, so we can understand what is behind the scene on this data. So now I would say first phase is done, meaning that we collected data into the MSS and we try to visualize the data to try to find out the pattern. This is, I think, very normal process what we do until now. But we don't stop here. I'm going to show you the next step, what we are going to do. The next step is using predictive analytics module. But again, what I'm trying to emphasize is that this predictive analytics module is not just for prediction. We use predictive analytics to see the more patterns in how this data is formulated and consisted. So, for example, if we only rely on regression model, then we can maybe we have difficulties if there are too much massive amount of data, or if there is any random outliers, unstructured data, right, or missing data. If there are this kind of situation, then it's very, very difficult just using regression model to understand the data, right? So that is another reason we use predictive analytics. So you can see the menus there, the models, different models or algorithms that we have, CARD, TreeNet, Random Forest. Recently, we added MAS as well. Not only this, if you can see on the top, there is automated machine learning. That means that this automated machine learning function will find the best fit model for you. So let's see. Let's find one model. Let's build one model. So the response is energy consumption piece, and then we will put the predictors of the 1 to 20, all these continuous predictors, and then also we will define product line and supply in the categorical predictors. And then we are going to limit the number of trees to 30 because 300 is too big. 30 trees is good enough to just see the data inside. Also, the analytics model inside also already very accurate. So, yeah. So we see we will have a good model. We click on OK, then it will run and load that, compare to different models and show the result. As you see the box, you can see the fit of regression model with a linear term, a term of order 2, fit 6 TreeNet, and 3 another random forest. We have, it shows that we run many different models, and you can see that there's about 70% of training data and 30% of test data. That means that we split training and test data and use training data to train this model and then compare with test data. Then we can see how this model is accurate, more accurate. So you can see here, you can see the R-square of the different model. The first one, multiple regression, 99.63%, random forest, CART, and TreeNet. All of them are very, very high R-square. That means a high, well, probability or fit models. But this time, we are going to pick TreeNet today because that means that the reason being the multiple regression is quite difficult to understand. I would say not difficult to understand. Like you see, the information is very complex for you to understand, also for your manager to understand. And so we are now going to switch over to the TreeNet. And you see, if you can select TreeNet, there are 6 models ran, and then the last one, number 6, with a 97.82 R-square is the best one. So we are going to pick this one. So there is a result here. So if you see, there's same split between the training data and test data. Yes, here we go. So training and test, you don't see deviation, much differences. That means training data and test data are very similar, consistent. And by the time around 33, we already reaching to the 97%. So that means 33 is already good. 30 knots, 3 is already good enough. And also, you can see total predictors 15 and important predictors are 8. Okay, this is a second very important output that you don't get from the regression. This is relative variable importance. So which variable has a relatively important in this prediction? The first one is production rate. Of course, like 100% reliance. The second one is pieces produced, which is 82.3%. It's relatively important. And production line third, low material fourth, until down to the strength. So the beauty of this output is you can see the list of the relative variable importance. And you can select, from here, you can select 4, like production rate to raw material or equip temperature. You can select most important variables and do more investigation. So let's say we've picked the first big 4, the most important variables. Then this is it. So if you see the left one on the top, you can see as production rate increase, also energy consumption also increase. So we can expect this is when this really the energy consumption is really rely on this production rate. The second graph you can see is a pieces produced order size, and the Y is energy consumption. So the energy consumption is being reduced until like 110 order size, but if it exceeds 130, then the energy consumption also increase. So you can see the optimum level of energy consumption based on pieces produces. The third one is on the left production line. You can see first 3 line A, line B, line C. The energy consumption level stay the same, but line 4 it just get increased. So you can see something wrong with the production line D, or whether this is age, whether this has some errors, problems. You need to revamp, renovation. So you can see that factor. The last one is low material. Again, if lower than lower than 2%, the energy consumption skyrocket. And of course, you can look at the predictor partial dependent plot. with a two predictor partial dependent plot, you can see the area, spot out the area where you can reduce the energy consumption. So this is quite powerful output. Again, not just it's very difficult just using traditional analytics, but if you use predictive analytics, then you can have another viewpoint to approach. So this time we will do another prediction model, but the response will be yield. So because we don't want to affect the quality, so we want to see the best yield as well. And we will compare this yield output with the energy consumption output. On the left, we have yield, and the right side, we have the previous energy consumption. But output is also very similar, the R square, and also let's see, the relative variable importance, not exactly the same because the yield and energy consumption is different. For yield part, the pieces produced is the most important factor, and then production line and production rate, and casting temperature is number 4. But it seems we have at least a production line and production rate is also important in this factor. So if we can improve this production line and pieces produced, then we can have both. We can improve both energy consumption and yield as well. So the previous prediction model, again, the pieces produce the most optimum level 110 to 130. And also at the same time, the yield as well is optimized around 115, 110 to 120. So that means if we can maintain the level of 110 to 120, then we will have both saved energy consumption and also optimum level of yield as well. Production line as well. Production line D had a lot of energy, consume a lot of energy. At the same time, the yield is also bad. That means that we should move production from D to A or B or C. Casting temperature, yield is not affected after 705, but if the temperature go down 705, then yield drops very dramatically. So we have to be careful about the casting temperature as well. So let's take a look at the summary. So what can be improved? What can be our short-term measure? The first one is the order size. We maintain the order size at least 115, so you can see it can be optimized. The second point, we may try to transfer some of the production from D to A or B. This one also the third one would be maintain the casting temperature over 705. So these three can be quickly fixed by just setting up the parameter and make sure your manufacturing team can meet this requirement. This one, you don't need to have any additional equipment, additional investment, additional like big changes. We can set up this parameter right away. So it could be, that's why it can be short-term measures. For long-term measures, line D was a problem because it consumes a lot of energy. At the same time, the yield is very low. So you may think about renewing or revamping this product line, D. And after all, you can generate this kind of chart for the management or decision makers. This is a quite nice tool that generated by Workspace. You can see Workspace improve phase. You can generate this form. So what you want to manage the to the management is the final chart, the Pareto chart with the figures. And you can, this is generated by this template that you need to put the numbers into those entities that with weighted scores. And then we will generate this Pareto chart that you can communicate very easily to your management or decision makers. Like you see, this criteria weighting you need to set up, and also you need to list down the proposed solution, how it's going to be affected. Yeah, everything there. So as a financial summary, the production plan with the average monthly consumption was 5 gigawatts, and average electricity price for the industry in the USA was about $84 per megawatt. So savings, they reduce energy consumption by 20%, which calculate to this figure, which is $84,000 per month, which is quite significant. At the same time, of course, if you can reduce down the energy consumption, then CO2 emission also automatically reduced. There will be addition. So for the next step, we can do a few more steps or a few other options to do. The first one is use predictive analytics to really prediction for the future energy consumption, and or the other one you can use Connect to set up the dashboard to track the energy consumption level, CO2 reduction level, and then if there's any like outliers or abnormalities, then you can send an alarm to your user or your managers. So let's go back to Minitab and see how we can use predictive analytics to predict the future consumption. So if you go into the Connect, then there's another sample data. This is next year plan, production plan. So we downloaded this table, the next year 2024 plant production. This plant production data was planned based on our the analysis from the predictive analytics. There is a pieces produced old and new. So old means without this saving, without this optimizing, there was old production figures. The new means with the new improvement enhancement, new parameter, how we should produce next year. This is two different data. So we will get the energy consumption pieces, energy consumption as output, and we select all the predictors. We will select only four from the top because those are the most important. And then we made a very simpler model with these four. Yes, you can see that to predict the partial plot, and you can just select the predict button, and then you can put which result you want to get. So again, like I explained, the old setting, the new setting. So we select the older one first. So you can see the production rate, pieces produced old, the previous setting, and raw material count and production based on the top important ones. So these are the results. That means with old setting, this will be the energy consumption result. We will do exactly the same thing with the new production plan, new parameter. Again, production rate, pieces produced new, and material contents and production line. Then we will have the second fit here. this is the energy consumption with a new parameter. Then we wanted a cumulative value, so we get a small macro to get cumulative figure here. Cumulative old and cumulative new. Then we can bring them to a graph builder, and we can set a time series plot and overlay those two lines. As you can see, this is a difference of energy consumption. At the beginning of the week, of course, it's a beginning, so the energy consumption saving is minimum. You cannot see much. But if you can see when the days are passed, let's say 161 days pass, then the savings will be significant. Almost 10% you can see. Of course, if time passes more and more, then you will get more energy savings. Okay. So, conclusion. Our summary, my summary this time is that first of all, it's easy to use Minitab solution. Again, you saw that everything was click and just put the numbers and get the result. Very easy to use. No code, just a click. Also, predictive analytics as well. So, and this is derived measures. So, when you want to set up the measure, new plan, must based on the experience, must based on the confirmed figures. So, all these figures are derived measures. So, you can discuss with expert with these figures. And database insight as well. The third point is easy deployment of insight, the forecast value, and work with dashboard and get result using Connect. Last but not least, this is how Minitab can help. If you need any software solution introduction information, or you need a training or consultation, please come to us. Yeah, we'll be happy to help you anytime. Thank you very much. Thank you.